example 1 here. Let's go over that one. That's a good place to start, right? Example 1. Here's what I'm going to do. I'm going to raise everything in this parentheses to the negative third power. So I have to do -3 to the negative third power. Make sure you put that -3 in parentheses too. Now, p squared to the negative third power, an exponent raised to another exponent, you multiply the two numbers together. So that's p to the -6. And then s -4 times -3, that's +12. Now, anything with a negative exponent, we're going to need to flip. So s to the 12th, nothing wrong with that, stays put. -3 to the third is now on the bottom of our fraction. P to the 6 is now on the bottom. And when we have moved them, they're no longer negative. And then the last thing you need to fix here is -3 to the third power. We can do that math. -3 times -3 times -3 is -27. Here's your answer for that one. All right, example 2. We have two sets of parentheses here. We are multiplying, and when you multiply exponents, you actually add the numbers. So w squared times w to the 4th is w to the 6th. X to the -3rd times x squared is x to the -1, and now we have a negative exponent that we have to correct. And that is your answer for that one. Example 3. If it was simply 3/15, wouldn't that reduce to 1/5? If it was m over m cubed, now remember, if you're dividing exponents, you subtract them. So m to the first minus m to the third is m to the -2nd. And now we have n squared minus n to the -2nd power. So that's going to end up being n to the 4th. Last thing we need to correct, let's take care of that negative exponent. And that's your answer for example 3. Example 4. 9/3, that's just 3. C over C, those cancel one another out. And d over d squared is d to the -1st power. And now take care of that negative exponent. That's your answer for example 4. For example 5, we're describing the end behavior of the graph of a polynomial function. The way that you do that is you identify what is the largest exponent. In this case, it's a 5th degree. This is a 5th degree function. If the number of the degree is odd, that means your end behavior is going to be going in opposite directions. Either up, down, or positive infinity, negative infinity, or down, up, or negative infinity, positive infinity. Now, we know it's one of these based on the fact that this is an odd exponent, 5th degree, that's an odd number. What's going to determine the final set of end behaviors here is what's our leading coefficient? That's the number in front of the largest exponent, and that's -2. Now, the 2 doesn't matter nearly as much as the negative does. What this tells us is, this tells us what our graph is ultimately doing. It's ending in towards negative infinity. So our end behavior here is up, down. Example 6. The largest exponent there is a 4. And if it's an even number, then you're going the same direction, either up, up, or down, down. Now, what determines that is the leading coefficient. Our leading coefficient here is -3. The thing that really matters is negative, and it probably stands to reason that our end behavior here would be down, down. Even degrees are a little bit easier. Example 7. Let's see, we're dealing with a 3rd degree polynomial. Its leading coefficient is +5. The thing that matters most is the fact that it is positive. Since it's odd, we're going in opposite directions. And since our leading coefficient is positive, that means our last arrow has to be going towards positive infinity. So your end behavior here is down, up. Number 8. That is a 4th degree polynomial. The leading coefficient is +7. The thing that matters most is positive. So since it's an even degree, same direction, since it's a positive leading coefficient, it stands to reason that these are going to both be going up, up. Example 9. Do not multiply these sets of parentheses here. There's a minus separating them. In this scenario, the first set of parentheses really is not needed. I'm just going to start writing it down. Now, the second set of parentheses, I need to take that negative and I need to distribute it throughout the parentheses. So it's going to flip all the signs. And I'm going to start aligning my like terms vertically here. So negative times x to the fifth, negative x to the fifth. Negative times x to the fourth, negative x to the fourth. Negative times negative 5x cubed. That's positive 5x cubed. I'm going to set that over here to the side. And then a negative times negative 1 is positive 1, and I'll put that here. All right, now I'm going to start simplifying vertically and putting it in the proper order. These cancel out. 3x to the fourth minus x to the fourth is 2x to the fourth. Now I'm going to include this positive 5x cubed because I'm going in descending order. Okay, I took care of that, took care of that. Let's see, minus 2x next. And then 4 plus 1 is 5. This is your final answer. For this next set of parentheses, once again, do not multiply. We're adding. And if we were to distribute the positive throughout the parentheses there would be no change in signage. So I'm just going to align vertically, starting with 5x to the fourth. Are there any other powers to the fourth? Yes, here we go. Positive x to the fourth there. And let me scratch those out so that I'm aware that I've taken care of those. Okay, I did that one, that one. Okay, 3x cubed. So let me write plus 3x cubed. Is there another cube term? Let's see. No. Okay, next, minus 2x squared. Minus 2x squared. Are there any other terms being squared? Yes, right here, minus 5x squared. All right, plus 4. Well, let me see if there's just a plain old x somewhere. Yep, right there. Let me start with that, minus x. I like everything being in order. And then plus 4. Plus 1. Now we're just going to combine like terms vertically. 5x to the fourth plus x to the fourth, 6x to the fourth plus 3x cubed minus 7x squared minus x plus 5. That is your final answer for example 10. Okay, example 11. If you have anything that is being squared, what that means is you have two of the exact same thing. And since we're dealing with a binomial here, two sets of binomials, we have to now FOIL m times m times negative n negative n times m, and negative n times negative n is positive n squared. And then combine your like terms. I can combine these two. Negative mn plus negative mn is negative 2mn. And that's your final answer there. Example 12. Remember your order of operations, parentheses first, then exponent, then multiplication division. Okay, well, I've just now taken care of the exponent. Well, the parentheses, there was nothing to solve in the parentheses. There's nothing we can do here, but I did take care of the exponent. I expanded our binomial here. And now I want to multiply these parentheses first. Let's do that first. M times m times negative 5. Negative 5 times m. Negative 5 times negative 5. All right, I'm now going to combine these like terms here. And I'm going to bring back this m and now multiply it throughout the parentheses. And that's your final answer for example 12. Example 13, we're going to factor this here. We're going to factor by grouping. This very first group here, a cubed minus 5a squared, you could factor out a squared. And that would leave you with a minus 5. This next group here, the 3a minus 15, you could factor out a positive 3. And that would leave you with a minus 5 again. Okay, so one of our factors is a squared plus 3. And the other factor is a minus 5. A minus 5. That looks like a 9. That's an A. And now it looks like a Q. I'm making it worse. Okay, let's see. 14. Here, you can start by factoring out a cubed. A cubed. And that would leave us with a squared minus 4. Oh my goodness, look at this. We can factor again. This is a difference of perfect squares. The square root of a squared is a, and the square root of 4 is 2. And now we have completely factored. All right, for example 15 here, factor the polynomial completely given the following information. To be continued. Okay, we're back. Example 15 here. Factor the polynomial completely given the information, and they tell you that x plus 3 is a factor. They're giving you a hint here. They want you to use synthetic division. If you set x plus 3 equal to 0 and solve, you would get negative 3. Okay, let me make sure I wrote that down correctly. Yes, okay, now synthetic division, if you don't remember, here's what you're going to do. Whatever the leading coefficient is, drop that down, don't change it. And now, from this point on, we're going to be doing multiplication, addition, multiplication, addition, until we reach the end. Negative 3 times 3, negative 9. Now add these numbers. 10 plus negative 9 is 1. Negative 3 times 1, negative 3. Now we're going to add these. Negative 1 plus negative 3, negative 4. Multiplication. Negative 3 times negative 4 is positive 12. We've reached the end here. I like to kind of keep this separate. Negative 12 plus 12 is 0. So that's our remainder. We have a remainder of 0. All of these variables now, I'm going to drop down and I'm going to decrease them by 1 exponent. So here's what we have left over. This is our quotient. 3x squared plus x minus 4. Now it told us to factor completely. So this right here is factorable. Number in front, number in times number in back, a times c, 3 times negative 4, negative 12. And these are the factors that we need because negative 3 times 4 is negative 12, and negative 3 plus 4 is positive 1. We're going to have to create a grouping problem. Okay, out of group 1 and group 2, let's take a look at group 1 here. We can factor out 3x, leaving you with x minus 1. Group 2 here, you can factor out positive 4, leaving us with x minus 1 again. And now we know what our factors are. 3x plus 4 is one of them, and the other, x minus 1. You would do that exact same level of operation for example 16, so I'll have y'all do that one on your own. For example 17 here, it's like all we're doing is factoring by grouping. Looking at this first set here, you could, out of x cubed plus 5x squared, you could factor out x squared, leaving us with x plus 5. Out of this second group here, negative 3x minus 15, you could factor out negative 3, leaving us with x plus 5 again. Okay, so our factors are x squared minus 3 and x plus 5. What it wants us to do is to find the real number solutions of the equation. So we're not done yet. We have to take each of these factors, set them equal to 0, and solve. This one here, you'd start by adding over the 3. Square root both sides. And if you're solving using the square root method, which we are, then it's plus or minus the result. So we have two answers here, positive root 3 and negative root 3. And then this last one here, you'd have to subtract over the 5. So we have now found all the real solutions. Last one, example 18, at least on page 1. This is the last one. I'm going to write this one down because we don't really see these very often. Okay, we're going to factor this as if it was a normal quadratic trinomial. Number in front, 1 times number in back, A times C, if you will. 1 times 12 is 12. Okay, these are the factors that we're going to need, and they both have to be negative. Negative 3 times negative 4 is positive 12, and negative 3 plus negative 4 is negative 7. So we have our correct factors. Since our leading coefficient is 1, we are going to use the shortcut here. We're going to save ourselves some time. If this is x to the 4th, your leading term is x to the 4th, then when you go to factor, they should be x squared rather than x. Why? Well, look, x squared times x squared is x to the 4th. So hopefully that makes sense. Now we're still finding the real world solutions here. So let's set these equal to 0 and solve. Add over the 3. Square root both sides. X equals plus or minus 3. Now over here, add over the 4. Square root both sides. X equals plus or minus 2. All right, that's page 1. I'll get the other pages to you as soon as I can.